everyone, my name is Udit. Today I'm going to talk a little bit about what a design verification engineer does. At the end of this video, you should have a really good understanding of what the role involves, what your responsibilities would be, and what day-to-day activities look like. This is an introduction video in a series which will focus on interview preparation for design verification roles. As always, I'm going to prioritize videos for which we receive inbound requests from candidates. So if you'd like me to prepare more content on this topic, please tell me in the comments below. As a quick introduction, I'm from Prepfully. We're an interview preparation startup that offers mock interviews with someone in your target company and role. So for this video, a lot of verification engineers from Intel, Samsung, Nvidia, Apple, Google, Facebook, a lot of companies which have hardware engineering divisions got together and put together this content for you. They're also the ones who've been providing a lot of candidates with mocks and advice. If you're interviewing at any of these companies for hardware roles, I'd strongly recommend doing a mock interview with one of these experts since they've helped a large number of candidates and can give you real-world practice and targeted advice on the gaps in your preparation. There's a link here where you can click and go to the website for booking this. So, on to what a design verification engineer does. In a nutshell, a verification engineer is responsible for designing and executing on test processes for hardware products and ensuring that they fulfill the purpose for which they've been designed. That's the short version. The longer version is that their job is broken down into 4 broad sequential steps: the creation of a verification test plan, the development of a test bench, or what a lot of industry insiders just call TB for simplicity, writing and then executing on test cases, and fourthly and finally, ensuring test coverage. In parallel, supporting stakeholders who are involved in the design and development process and test process is also a crucial part of this job. So this could be design engineers, it could be architects, it could also be other verification engineers who might be testing at different levels of the stack. I'm going to talk about each of these 4 things in a little bit more depth so that you actually understand what the job involves. So the first then is the creation of the verification test plan. This varies a little bit across companies, but typically involves the creation of a verification strategy and a test plan. It starts off with multiple discussions with design engineers and architects involved in actually designing a chip, and it culminates in a test plan designed to robustly test the functionality of this particular component. It's an essential step because the document you'll put together at this stage will get continually referred as a guideline throughout the entire test process. Step 2 then is the development of the test bench itself. This is the infrastructure you set up to use the design and verify its functioning. There are 3 sub-steps to this. Sub-step A is the VIPs you choose to use. Sub-step B is the verification methodology that you choose to employ. The most commonly used is probably UVA, for instance, but different companies use different flavors such as UVM or plus OVM or UVM plus VVM. To some extent, this is determined by legacy methodologies that companies might find challenging to evolve away from. So it's useful to know what different companies use when you're interviewing at one of them. Sub-step 3 is test bench architecture, and this is super important because this is all around determining the optimal architecture for each use case or challenge that you're testing. For example, let's take the case where the design has a CPU, which isn't always present. In this case, you'd ideally want to have a C test at an SOC level, and potentially unit tests would be written in Verilog. Determining what the right architecture is for each component and for the overall chip is what this step is all about. Cool. Step 3 then, the development and execution of test cases. This too can broadly be divided into 4 sub-steps. Sub-step 1 is sanity test cases. So these are basic tests which ensure that things are broadly working. If you're testing a memory controller, for instance, you'd want to read and write randomly in a few locations. If you're testing a data arbiter which say accepts 10 inputs and produces 2 outputs, then randomly testing to see if this mapping is working correctly is what this sanity test is going to be all about. Sub-step 2 is feature-related verification. So for example, let's say you have an arbiter that accepts 2 inputs, audio and video, but should prefer the video when producing the output. You'd want a test case which explicitly tests this. Another example, let's say you have a CPU that once powered on should take 10 seconds or 10 microseconds to boot up, but should always boot up within 20 microseconds. So now you'd want a test case explicitly to test this. You should try sending a signal just after 10 microseconds and then checking if it gets sent. Otherwise, it's a signal that something's wrong. The third sub-step then is advanced and corner cases. So multiple scenarios occurring together, for instance. This often becomes a super detailed spec and can often run into hundreds of pages. Which is why the next step then, the fourth sub-step, is so important, which is randomization. It's never going to be realistic to cover the entire test spec when you actually execute on these tests, because there are millions of possible scenarios. Ideally, you'd want to create an algorithm that randomizes these inputs to test a large diversity of scenarios. Finally is the actual execution and debugging support. So you're going to find bugs, you're going to find issues when you're running that chip through tests. And ideally you'd want to ensure you support and debugging this and fixing any design issues with the help of a design engineer. Next, and very importantly then, is step 4, which is all about ensuring test coverage. In this step, you're finally trying to ensure that you cover as many possibilities as possible within your test cases. There are 2 metrics you usually use. The first is total coverage, like is each critical part of the design tested or not? And then there's functional coverage, which is are all major combinations tested, are corner cases tested, and edge cases covered? What's the degree to which we cover those millions of possibilities within our test scenarios? Finally then, what I previously alluded to in the beginning as well, underlying the actual technical tasks are the coordination and support related tasks. All the way from involving stakeholders such as architects and designers at the early stages, to passing information to other verification engineers who are operating at different levels of the stack, from IP level to subsystem or cluster level to SOC level verification, to then again involving designers or architects when you find issues or you want to report these findings, which of course means communication, interpersonal skills, persuasion skills are going to be a really important skill that you're going to use on a day-to-day basis. Good, that's all from us then on what a design verification engineer does. As I mentioned earlier, this is the first in a series of videos which is going to explore what the role is. Follow-up interviews will likely be much more interview specific. And I also want to, in follow-up videos, provide tips and tricks on how you can crack this interview. If you have specific topics you'd like me to focus on, please mention this in the comments. And again, if you're interviewing for this role, we've got experts from Intel, Nvidia, Samsung, Google, Facebook, pretty much all major companies that hire for this role. And I'd strongly recommend a mock interview with one of them. They give super targeted advice on what you're doing well and where you need to improve. Once again, you can book that on that button here. As always, I'm going to prioritize the next few videos based on engagement. So if you found this useful and would like me to prepare more content, let me know in the comments below. If you found this useful, don't forget to like and subscribe. Thank you.
Thanks for watching the video. If you liked it, please subscribe. Our website is prepfully.com. We've got lots of interview questions there. You can also schedule a mock interview with one of our experts. You can find the link in the description below. All the best from us at Prepfully, and we hope you totally rock your interview.